Hey everyone, welcome to the SIG Node meeting on March 3rd, 2026. We have a couple of agenda items. The first one is a request, I believe, just for a review, a couple of reviews. So if someone could take a look at those, that would be great. The first discussion, I think, is Tim.
Hi. Uh, yeah, so I have been prototyping a change to do on-demand relisting of individual pods in the plague. And I finally got it working end to end and got some really promising initial results. And so I wanted to bring it to this group to kind of gauge interest in this direction and sort of figure out what the next steps are. So very briefly, the the insight is that most of the operations that the kubelet performs through the runtime, through the CRI, are actually synchronous operations. So start container, when that call returns, the container will actually be started. This is how it works in container D. I assume it's the same in cryo, um, since they're both using run C under the hood. Um, and so once the kubelet finishes syncing a pod, if it's made any changes, performed any actions through the CRI, it knows that we know that there's immediately going to be a new state that can be read through the plague. And so rather than waiting the full 2 seconds or however long it is to the next global relist, we could just relist that pod on demand and immediately proceed to the next sync iteration, which means kind of reporting the status back up to the API server much faster. The other piece of this is when a new request comes in, so for instance, a resize, normally if it triggers a sync pod request that doesn't come from a plague state change, it has to wait before executing sync pod for the next update on the cached state. And so we can also trigger the on-demand relist before entering into that initial sync pod. So anyhow, initial benchmark results, I was looking at pod creation latency and resize latency. Pod creation latency on my benchmark, this is just running locally via a kind cluster. It dropped pod creation from an average of about 1.8 seconds to about 1.1 seconds, which is a pretty substantial improvement. And then more notably for resize, it was about a 10x improvement from, again, an average of around 1.8 seconds to about 0.1, 0.16, 0.18, somewhere in there. So yeah, that's the summary. I guess my questions for the group are sort of, how do folks feel about this direction? And is this something that we would be open to taking in 136, or does this need a full like KEP review cycle? Sergey?
I like where it's going. I think it makes sense, and it's something we were trying to do with evented flag as well. So evented flag kind of go in the same direction. As soon as you have an event, you will process it. So kind of, I think directionally it's a good way. Did you perform any bootstrap comparisons when we have like I don't know 256 pods starting at the same time? Will they start colliding with each other? Like, do we need to have some optimization in this logic? I think maybe somebody else can think of other scenarios, and depending on how confident we are in the scenarios, we can answer the question of 136 versus cap.
Just
Yeah.
echoing what Sergey said, this is definitely a good direction, Tim. It was the intention, the original intention of the plague was so that you could actually shortcut these. Yeah, this makes a lot of sense.
Yeah, Sergey, that makes sense. I'll add a benchmark for that as well, starting a whole bunch of pods at once. Yeah, so this has a lot of overlap with the evented plague. My initial thought was like, is it even worth going in this direction, or should we just be pushing more towards evented plague? There's an issue I filed. I'll link it into the agenda after. But when I ran the benchmark against the evented plague as well, I actually ended up with worse results than the generic plague. And the reason for this is, I guess this is a known issue, but it was news to me. There's a race condition where suppose a new pod is starting, the kubelet starts a container and immediately gets back an event, container started. The evented plague processes that event. It causes the pod status to get updated in the cache, and the cache timestamp on that gets updated. Meanwhile, the sync loop is still proceeding. And so the sync loop finishes after that event has already come in. And then at the end of the sync loop, it sets the last sync time to now. And so on the next sync iteration, the pod status is older than the last sync time. And so it has to wait until the next 5 second, wait the full time for the next global relist. And so we actually lose out on the benefit of those on-demand events. I'm not sure of a good way to solve that. Yeah, go ahead, Mike.
Yeah, one of the things I wanted to mention on this topic is that we're needing to split the run pod sandbox into a create and a start, similar to how we do containers today, just so we can handle sandbox management a little bit better. And that should also increase the performance considerably. Because of Sergey's question about how many pods can I run at one time? It really comes down to how many do you want to create, and then when do you want to start them, right? Based on the ensure issues.
Yeah, circling back a little bit to the evented plague issue, like, yeah, I guess I mean this is great results, obviously, and definitely am open to going forward with this. It does feel like, a case of like, does the SIG want? I mean, we've been languishing in evented plague for a while. We do have Bing, who has been sort of trying to champion it for a little bit. We haven't putting a ton of energy into it. I guess the question is like, do we feel like it's a lost cause to try to go for evented plague? In which case, I think that this improvement makes a bunch of sense. If we do eventually want to be going for evented plague, part of me wonders like whether further complicating generic plague on top of that might, like, I don't know, just sap energy or like continue to complicate, the evented plague to the point where we'll continue to sort of let it languish.
I've been thinking about this a lot. I think a hybrid approach might be the best, actually. So what this is really good for is the kubelet took an action, and now we want to immediately read back the results from that action and perform the next sync based on that. I think where the evented plague really shines is something happened outside of the kubelet's control. So a container was killed or spontaneously died or terminated for whatever reason. There we don't have any signal that we should go do the on-demand relist. And so that's where I think the evented plague really shines. And then the other thing is in the create path, not only is there the issue that I mentioned earlier, the race condition with the last sync time, But suppose the kubelet is starting a new pod. It creates the sandbox. It starts the sandbox. It creates and starts 5 different containers and whatnot. Like each of these is going to trigger an event. And if we're relisting the pod or like refreshing the pod status with every one of those events, that's going to be a lot of updates that essentially just get overwritten by whatever the last one is in that cycle. So what I've been wondering is, should we actually discard like these create and start events entirely and just rely on the on-demand sync, and then use the evented plague to get the sort of the termination signals? I think a slightly more principled approach, I'm not sure if it's worth the complexity, but we could basically like treat the sync loop iteration as a transaction on the pod. And so, while we're in this sort of like locked sync state, we sort of discard any events that are coming in and just like queue them up for a sync after the loop finishes. So either way, it sort of ends up being reusing a lot of the same mechanisms here.
Yeah, I like the idea. I think your logic behind like discarding the create and start events is really sound, and I think that like a hybrid approach does make sense. The other thing I'm then thinking about is like you mentioned. I haven't actually looked at your PR yet, so I need to sort of. I might be a little out of date, but your after the kubelet is like, I started the pod, is there another CRI round trip after it gets the response like started from the CRI? Is the kubelet rechecking in your new PR, rechecking with the CRI like, okay, is it really started? Or is the callback going up rather than back down?
I'm not sure I totally understand the question, but basically, kubelet performs a bunch of CRI actions. At the end of the sync loop, it says, were any sync actions performed? If yes, then immediately request a relist on the pod, which will fetch the updated status, which will trigger another pod sync. And then since we publish the status to the API server at the beginning of sync pod, this means that the API server will get the signal that the pod is running much more quickly.
Yeah, I guess so. Then I feel like another avenue that could be a potential optimization, and then potentially would then maybe make this more of a KEP scope. So we can argue whether or not that makes sense. Is like have the CRI return the pod status when it does one of these status changing things, so we don't even need that second round trip. Like the kubelet is currently, and also with your PR, doing two operations of the CRI. It's like the write operation and the like setting the status, and then the read operation being like, did the status get set? But we can, if we're assuming, which Cryo does also do it synchronously, if we're assuming that this is going to be the case, then, and we can codify that with CRI test and stuff to make that clear, then we could have the CRI return the like status changes of what it did change, and then the kubelet wouldn't even need to recheck. It could just immediately start syncing that with the API.
Mm-hmm.
Yeah, I don't know how much we want to go into design discussions right now, but Peter, what you described makes sense, but I think it will complicate logic a lot. We had a similar thing with DRA health status when we we had a choice of returning status or like it's also evented, like so DRA device status may change independently from what kubelet is doing. So on the status change, we had a choice of trying to update or return the changed fields and try to reconcile it with the status that pod already has, or has this logic of events being separate, like events just saying, please release this pod status, and then pod status will be updated. And for the array health check, it may, I wouldn't mind going, like if the array device status changed, maybe we need to go to CRI as well. And like all this logic to update the pod status should be kind of the same whatever signal we received. And probes may give you a signal, evented flag eventually may give you a signal, and I really want to detach the signal receive status from like how you update the status, how you map the current runtime status to the pod status.
Yeah, I see. Um, I understand where you're going with that. I guess what I feel naively is like, and obviously, um, speaking a little bit early, but like, is this if the kubelet is just going to immediately query the CRI right after, asking for something very similar to what it itself knows, and we as developers know has just happened, then maybe we can short circuit that. So this is not so much in the event mode where we're like, a pod stopped and we're reacting to that, but in the sort of transactional mode where the kubelet is doing things and the suggestion is that we like double check that something was done. Whereas I feel like, yeah, but that's potentially maybe not even that useful. Like it might not even be that big of an optimization. So it might not be worth the complexity. And yeah, just was something that I found myself thinking about.
Yeah, absolutely. It's not wrong to go this direction. It's just I have a feeling it will complicate code a lot.
Yeah, totally.
I like Tim's idea about filtering the number of events that we're doing and just going to the exits because that's a special process. The other issue, just to mention, that we have today is when you're including the pod status with the plug events, that requires a muxsem across that pod. So if you're also adding new containers to it, you might get locked up and might have to wait for that evented plug to be either noticed or right. Just takes more time because it could be blocking other things because we're using the checkpointed status, not an in-memory cache status. I'm not sure how the cryo implementation is, but we should probably do some analysis, some benchmark analysis.
Yeah, the cryo implementation is quite a bit simpler because we don't actually have an API underneath it. We're just, so, but yeah, I think, yeah, I would be interested in having this corollary discussion about the state of evented plague, probably asynchronously on the issue or something like that, because Bing, who is driving it, it's too late for them to make this meeting. So, yeah. Uh, cool. Did anyone have any other thoughts on it? Yeah. So I guess I don't really yet have a answer to your question, Tim, whether this scope is large enough for a cap. So I think that is still an open question.
Yeah, we can take some of that offline. I think, in terms of next steps, I think more testing is needed on my end, both manual and automatic. I'll add that benchmark that Sergey asked for. And then, yeah, I guess at some point, someone needs to make a judgment call of, are we comfortable taking this change in?
Yeah.
Beyond
Beyond scalability, I don't feel there are many edge cases, and we already have precedents when we short circuit pod status update with like probe changes and stuff like that. So it's not a totally new functionality. So maybe for scalability we can mitigate it by having a feature gate that is implementation feature gate.
Okay.
And interestingly, actually, it seems actually Bing added an agenda item to this meeting, which I didn't notice until right now, about evented plague, which I'm sort of summarizing. I'm trying to get the summary of right now. So we'll probably also maybe talk about that in a moment, but I guess we could honor the queue and switch gears to CRI image service v2.
Okay, it's me. I'm trying to share my screen now. Okay, I will start talking and I'll figure out. Okay, I'll start talking and I will stop trying to share my screen. I have some problems. You can open the document I linked, and I will just walk through this document briefly. So the context for this document is we had a lot of asks to change or implement new features on image pooling. I listed in the end of the document just issues I found from briefly looking at the repository, but I remember way more use cases and scenarios that were brought in. And for every scenario, the story went very similarly. Contributor will come and say, I really want to help doing it. I know how to do it. I just need a small change in CRI API. And change typically would be bigger than updating a structure in backward compatible way. Typically, since our API is not very flexible, it will be replacing one of the methods completely with a new implementation, or introducing new semantic for CRI API. And the follow-up question is always how it fits with all other scenarios that we want to implement for image pooling. And at that stage, we typically lost contributor because finding all use cases is a tough job, and we need to list them all, try to understand priority, and then figure out how much of a change we're willing to take and how much of a pie we want to implement in one go, and how much of it we can stage and implement step by step. So I took it on myself to start listing all the use cases that I know of, and it was also very motivated by AI/ML wave of improvement that we currently have. So I listed all the scenarios, and I was trying to imagine the new CRI API, and I get to the conclusion that CRI API will need to go to V2, and it will be very incompatible with what we have now, with many new assumptions, with a lot of new knowledge on kubelet. And at that point, I kind of paused and started thinking whether we know enough about our future to take this step and transition to V2. The reality today is the industry changes so frequently and so fast that our changes made today may not satisfy the tomorrow scenarios. Like we have requests on some um, uh, writable layers and like sharing more information than just image, and like sharing images across nodes, and we don't know yet like what other new formats of images we may need to implement to satisfy those new scenarios. And since we don't know the future yet, and the future we know may not be that different, like it doesn't change that much, I started like taking a step back, and like that's why document is not proposing any new um, CRI API yet. It just lists all the use cases, and I'm trying to understand which of those use cases are very important and can be staged um, for implementation. So the ask for this group is if you're interested in participating, shaping the CRI API v2 for image management, or you have like very pressing scenarios that like definitely needs to be there, and you need to work on that. Uh, Please join me in writing this document, understanding the priorities, and then once we have those priorities straightened up, we can go ahead and implementing them. And it will be easier this time because if you know all the use cases, and we know like we all agree on the scope overall and a roadmap, then we can understand how this roadmap maps into specific next steps. Um, anyway, so to just give it a little color, what we're missing today is AI/ML brings new challenges with large images, and if you take inference, for instance, AI/ML inference, for inference there is a base image with model server that typically contains of like sometimes it's like 11 gigabytes, and this 11 gigabytes of um, consists of a few drivers and like CUDA libraries for different accelerator types because inference likes to be fungible and runs on different device types. You can package less, or you can save like 3 or 4 GB of not packaging all the device types, but not many people doing it. And then there are like some Python, bunch of Python libraries that you need to bring together, and there are some other things that you package into your 11 gigabytes base image. So base image by itself is already huge, but then on top of it, people start bringing in weights for the model as images, and we even created OCI layer, OCI volume source, OCI image volume source cap is currently being G8. And this weights image may be like 20 gigabytes, like some there are different, like depending on the model that you serve, it may be huge. And right now we don't like right now we allow image pooling as normal through a registry, but it's typically a very long process, and not many people go through that. And many vendors start implementing different uh, ways to optimize it, from peer-to-peer image pooling to image streaming from file systems that is being mapped to some remote location. So all of these techniques improve the image pooling, and um, we get good results, but they all meet this edge cases for let's say for model streaming through for streaming based reg snapshotters. Like snapshotter is a container term for backing of file system with remote location. So for stream based snapshotters, we have a problem that those needs to be re-authenticated sometimes, or like they shouldn't assume that layer is available once it's pulled. And we had a container summit, and many people said that yes, they have this implementation and they have this problem. So we may start solving this problem, or we can just keep using those hacks and workarounds that people implemented. So yeah, I listed many more scenarios there. Please feel free to read and add your own. And now, Brunel, you have a hand.
Yeah, so sorry, I think we may have talked about this before, but like in this doc, have you considered like decoupling the life cycle of image from the life cycle of the pod and treating it as a first class entity? And then we can have scopes where a life cycle. So in many scenarios, if you know, like pre-seed images and so on, we don't necessarily need to have a pod running or a daemon set running, right? We can just have an API that can be used to pre-seed images on the nodes, and then pod can end up using that image. So I'll put that in the doc if it's already not there, but want to raise that here.
Yeah, that definitely will be a scenario. Whatever object will back up the image, we will need to allow early pull of this image. It's definitely there already, but I didn't talk about backing image as a. So I talk about not garbage collecting the image while it's being pulled by pre-pull, but I didn't talk about specific objects that will back the image pulling. So be it CRD or be it some other new entity. So I didn't put specifics there. I just put a use case. That said, even if you implement that, CRI API needs to be extended to allow fairness and faster bootstrap. So one, like pre-pooling images will not block image from being like initialized in the background. So we need to allow pre-pooling and execution of system workloads, meaning that system image pools may be taken a little bit may temporarily pause pre-pooling and like pull themselves and then resume the pre-pooling. So some fairness and some new APIs will be needed to implement that.
Yeah, makes sense. I think we can collect the use cases and then iterate on what the shape looks like for the implementation.
Sergey, one question. I mean, the ideas that you have, I mean, will it also be backwards compatible, or it means that it will require a migration if this will be materialized?
I think Yeah, I failed to imagine backward compatible API. So like if we implement all the use cases, it's likely will be completely new API. And it also means that we need to have a serious conversation between CRI and Containerd, how much uh, they need to differ on this logic and how much that can be developed together. Um, we see that like Docker, for instance, completely switched to Containerd as an image backup store in latest version by default. So there is a possibility for unification for sure. That said, if we decide that all scenarios are great and the roadmap ahead is like completely revamping the API, but in the immediate future we want to just change couple APIs and it's aligned with the long-term vision, it's also totally doable. And that's why I want to collect all the use cases and not have this conversation like what other things we need to think about for every small cap.
Very, very interesting topic, Sergi. Love to join this work group.
Thank you.
I think there's definitely Murnau and Peter a good opportunity to normalize some of the capabilities that we currently have, like multi storage drives, multi cache the Cryo has, and then using the runtime handler and certain labels from the pod to do registry integration. Some of these registries need a label that you stick there before you can do a pull. Things like that for Windows, right? So I think there's definitely some use case scenarios that we could come up with to, and then do an API. I think that would be very, very useful. I'd
Yeah.
like to fix resolve, for example. We need to clean up auth so it's a separate API. And as Sergi mentioned, we need to be able to store or persist encrypted in an encrypted way some of these keys so that we can, resume, right? Resume download and save a hell of a lot of, CPU and network speed.
Okay, thank
Yeah,
you.
that sounds great. Thank you for the presentation. Definitely also interested in participating. Yeah. Did anyone have any other thoughts on this? Cool.
I'll poke it in there. We need to fix mirrors too,
Yeah,
proxies. Yeah.
that's in there.
Yeah,
And
and
it's
I know you guys are already doing artifacts work, and we probably need to cover that. Yep.
yeah. Okay, so circling back a little bit back to Evented Plague. So this doc that Bing posted, I can share it. Basically it seems like the conclusion is like waiting for the SIG to sort of figure out whether or not we want to do Evented or generic Plague. And that was partially the reaction that we had before. I like Tim's suggestion of the hybrid approach, and maybe we look at teasing what that would look like out a little bit. But yeah, so I don't have I think that this document is in alignment with what we were talking about before, where basically we just need to figure out what we want to do, which one. Tim?
Yeah, I looked through a bunch of the changes that Bing had queued up and was benchmarking here. And some of them are actually pretty similar in idea to what I was doing with the on-demand relist. They're a little kind of specific to the Evented Plague and uh, yeah, so I think the on-demand stuff is sort of a generalization to some extent of
Yeah.
the work that was done here. So we can probably reuse a lot of that as well.
Yeah, and I think rescoping the work of Evented Plague to not necessarily include this on-demand like pod status piece and just be, quicker responses to pod exits could be a good sort of differentiation of the two pieces. and an easier way to maybe move forward with evented plague.
Yeah.
Because it's kind of complicating everything to the point where it's getting stuck right now.
Yeah.
Cool. Did anyone else have any thoughts on that? Right. And then last, it seems we have a Wrangler update. I think that there also is actually a review request that is down here as well. But yeah, so Wrangler update is just yeah, calling out that code and test freeze is the 18th. So get your code changes in if you have any, and also as reviewers and improvers, let's keep an eye out for those. And also it'd be really, really cool if we didn't miss any docs deadlines this release. So after the code freeze, we should also be very careful. Like we should make sure to keep up with the docs deadlines as well. Awesome. And then lastly, there is a review request for this event spam burst option in the kubelet, which I did look at, and I think it makes sense. The underlying issue, there's like a couple of different options that we could go to fix this issue, and I think that this one is the most straightforward and least disruptive to workloads or to a default cluster, because otherwise we might have to change default behavior. So please take a look at that. Did anyone have any other agenda items to work through? Awesome. Well, then I think we can adjourn a little bit early this week. Thank you everyone for joining. See you next week.